Welcome to the Explainer. So, you're gearing up for your Oracle PL SQL certification? Well, you are in exactly the right place. Today, we're going to demystify one of the most critical and, honestly, frequently misunderstood components of database programming, cursors. Let's dive right in and get you ready to absolutely crush this exam.
Think about this for a second. How exactly do you process 200 rows in a language that was literally built to handle just one? This is the fundamental conflict of PL SQL programming, and understanding this core problem is the absolute key to mastering cursors. You see, a database loves to hand you large chunks of data all at once, but procedural code is like a factory assembly line. It needs to work on one single piece at a time.
Here's our roadmap. We're going to cover bridging the database gap, implicit versus explicit cursors, the four-stage lifecycle, the cursor for loop, advanced performance control, and finish off with the high-value exam survival guide. Let's jump right in. Section 1, Bridging the Database Gap. Let's lay down the conceptual foundation. Right off the bat, we run into a major mismatch between our two main languages here. SQL is set-based, right? You run a select statement, and boom, it returns an entire result set all at once. It's a bulk operation. PL SQL, on the other hand, is a procedural language. It steps through logic one statement at a time and works with single scalar variables. It's kind of like SQL throws a whole book at you, but PL SQL can only read a single page at a time. There's just no natural way to cram a 200-row result into a standard PL SQL variable. And that is exactly where the cursor comes in to save the day. It bridges this gap. When Oracle runs your SQL statement, it sets aside a private chunk of memory, called a context area, to hold that active set of rows. The cursor, it's literally just a pointer to that area. A great mental model to keep in mind is this. The active set of data is your book. The cursor is your bookmark, and fetching is just the act of reading the current page and moving that bookmark forward. It turns a massive bulk result into a manageable step-by-step process. Moving on to Section 2, Implicit versus Explicit Cursors. Every cursor falls into one of these two buckets, and knowing the difference is an absolutely crucial milestone for your exam. So let's talk about implicit cursors first. These are automatic and totally invisible. You don't declare them, open them, or close them. Oracle does all that heavy lifting invisibly every single time you run an insert, update, delete, merge, or select into statement. Now, explicit cursors are the ones you actually build yourself, when you know a query is going to return multiple rows and you want manual control. Here is a massive insider secret for the exam. If you physically type the word cursor in your declaration section, it's explicit. Literally everything else, handled implicitly by Oracle. Now you've got to watch out for this fascinating trap. It shows up on almost every exam. Implicit cursors have attributes you can check, like row count. But the attribute SQL%ISOpen, that will always return false, no exceptions. Why? Because Oracle automatically opens the implicit cursor, runs the SQL, and closes it all before your very next line of code even gets a chance to execute. You can literally never catch an implicit cursor in the open state. All right, Section 3, the four-stage life cycle for explicit cursors. When you're expecting multiple rows, you've got to use an explicit cursor. Basically, you're driving a manual transmission car now. Let's break down how this lifecycle actually builds out across four stages. Step 1 is declare. Now, remember, declare does not touch the database. It just defines the query. 0 rows are fetched at this point. Step 2 is open. This is where the magic happens. Oracle parses the query, binds the variables, executes it, and locks in that active set based on the data at that exact microsecond. Step 3 is fetch. You'll usually do this inside a loop, grabbing a row and advancing the pointer. And finally, Step 4, close. This releases the memory. You know, if you forget to close them, you're eventually going to hit a maximum open cursors error and completely crash your session. Not fun.
While you're looping through those fetches, there is a massive trap waiting to catch you off guard. The exit statement that tells your loop to stop? It absolutely must be placed immediately after the fetch and before you do any processing. If you put that exit check after your processing statements, the cursor fails the fetch on the final pass, but leaves the old variables sitting there from the previous run. The result? Your program embarrassingly prints the very last row twice. Don't let that happen to you. Looking at the state of cursor attributes across this life cycle, there's a huge gotcha hiding right in the middle here. Pay attention to the state after open, but before the first fetch. At this exact microsecond, the found and not found attributes are null. They are not true and they are not false. Why? Well, you haven't attempted a fetch yet, so there's no result to report. The test makers love, and I mean love, to see if you'll assume it defaults to false. It doesn't.
It is null. Okay, Section 4, the cursor for loop. Typing out those 4 manual steps gets pretty tedious, so let's check out the automatic transmission equivalent. The cursor for loop compresses that entire lifecycle into one clean, beautiful construct. You literally just say for record in cursor loop, and Oracle takes the wheel. It automatically declares a record variable for you, opens the cursor, fetches the rows one by one, exits seamlessly when the active set is empty, and then neatly closes the cursor when it's all done. And because Oracle handles the whole shebang for you, if you try to manually open or close a cursor used in a for loop, you will instantly crash your program with a cursor already open or invalid cursor error. Seriously, just let Oracle do the work. Section 5. Advanced Performance and Control. Let's level up a bit and see how professionals optimize their code with parameters and locks.
So, when you want to reuse a cursor for different values, you use parameters. This makes your cursor totally reusable and explicit, instead of relying on external variables. But you've got to remember the rules here. First, they are in mode only. A cursor parameter cannot return a value back to you. And second, which is huge, you cannot give them a size constraint. You write vrchr2, not vrchr2 of 30. You write number, not number 6,2. It dynamically takes its size from the value you pass in at runtime.
Now, concurrency control is where things get really interesting. If you add for update to your cursor declaration, Oracle locks those specific rows the exact moment the cursor opens. That means nobody else can change them while you're working. And if you're updating rows as you read them, the where current of clause is amazingly efficient because it uses the internal row ID to instantly find and update the exact row you just fetched. But here is the ultimate warning. If you commit inside that loop, you instantly release those row locks. Your very next loop iteration is going to throw a runtime error because the cursor's lock is broken. Always commit after the loop is completely finished. If you want to supercharge performance, professionals use bulk collect to fetch rows in batches instead of one by one. This drastically reduces the context switches between PL SQL and SQL. You cap that batch size using the limit clause. But watch out for this trap. When you're batching data with bulk collect, checking %not found to exit your loop will maliciously discard your final partial batch of data. The not found attribute triggers the moment a fetch returns fewer rows than your limit, even if it did return some rows. To exit safely, you always want to check if the collection count is 0 instead.
And finally, Section 6, our high-value exam survival guide. We've covered the mechanics, so let's synthesize this into the absolute highest yield facts you need to memorize for exam day.
First up, the behavior of returning 0 rows. This asymmetry is a classic trick on the test. If an implicit select into statement returns 0 rows, it violently throws a no data found exception and halts your program entirely. But an explicit cursor fetching 0 rows, that's actually not an error at all. It just quietly sets the %not found attribute to true and lets you handle it gracefully in your code. Next is understanding row count. Never forget that there is no magical attribute that tells you how many rows a cursor is going to return before you actually fetch them all. The row count attribute is literally just a running tally of the rows you fetched so far during your loop. If you check it right after you open the cursor, it's going to be exactly 0. And that brings us to our final thought. We just spent this entire explainer learning how to master cursors, how to loop through them, lock them, and bulk collect them. But the ultimate performance principle is this. The absolute fastest cursor in Oracle is the one you never had to write in the first place. Next time you sit down to write a declar block, I really want you to challenge yourself. Are you falling back on procedural habits when modern SQL could handle the exact same logic in a single set-based pass? It's a question that separates the beginners from the absolute masters. So what kind of developer are you going to be? Think about it. Good luck on the exam, and I'll catch you in the next explainer.